Hello and welcome. My name is Mehdi, and in this video I'm gonna be tackling an exercise on Codewars from the perspective of an enterprise Java developer. What does it mean? Well, it means that I'm gonna be adding a bunch of classes, methods, and tests that I'm probably not gonna be using ever again, but I'm required to add them to be enterprise compliant. This is probably going to be part of a series, but I may change the format in the future. Thanks for watching. Enjoy. The idea of this exercise is to return a string t, for which each substring, let's call it is of I, is either less than or equal its next substring is of I plus 1, or bigger than or equal the next substring, following this simple formula. First, let's prepare the workspace and let's create a new package. So I'm going to be using Java, and in this exercise we can go up to Java 11. I'm going to call the package as the name of the exercise, up and down, and then I'm going to create a class up down as in the exercise definition. Let's start by getting the project to compile first. We're going to just return a null value as a starter, and then I'm going to copy the tests. I'm going to be changing a little bit as I'm using GUnit 5, and I'm going to have a test method rather than all the tests in one method. So let's run. It's compiling, and the tests should be false. Exactly. So the first thing that we can do is to split the text. Now in the exercise, it doesn't mention what a phrase contains, but I'm assuming it's spaces only. So let's start by spaces and let's see. So I'm opting to call the substrings phrases. The idea here is that I create a queue and to then seek the head of the queue and to peek to the next item. So let's extract it into a new method and let's create a class called text, as this is an enterprise edition. Okay, so we're gonna iterate as long as we have some elements. Just for info, in the Java queue, there is a difference between remove and pull. So both removes the head of the queue, but pull would return null if there is no element, but remove would throw a no such element exception if no element exists, if the queue is empty. Peek, however, is more or less is the equivalent to element, but peek would return null otherwise when otherwise element would throw a no such element exception if there is no element. Now, when we call peek after a pull, we're going to be returning the head of the queue. So we remove the queue in the first pull and then retrieve the next head with the peek. And the idea is to check their lengths. Now here I figure out that a queue won't work because I'm going to be either removing the first element or the second element, which isn't possible to do with a queue. So I'm going to be using a list, and I'm going to push in the results into a new list rather than changing the elements of the existing list, the phrases list. So if the head's length is less than or equal to the next phrase length, I'm going to be removing the head and pushing the head into the results list. Otherwise, I'm going to be removing the next element, which is index 1, and adding the next element into the result list. Now let's check first if there is an element, then we do this whole procedure. If there is no element, then we're just going to push the head, meaning that it's the last element in the list. So let's run the first test. So we have an infinite loop, and it looks like it's because we never removed the head from the list at the last iteration. Let's rerun the test. We should have some feedback. Yeah, exactly. It's running, but it's not correct. Well, the issue is because we're only testing for less than or equal. We never check if the substring is of I is greater than or equal the substring is of I plus 1. So let's correct this. So we're going to be alternating between less than or equal and greater than or equal. As we're not using a for loop with an index, one solution would be to use a boolean and to change the boolean states at the end of each iteration. So we're going to be using this boolean is lower than, and we're just going to be checking if less than or greater than or equal at each step. So it's correct, but there is an issue with the alternation of uppercase and lowercase in the actual result. So let's try and fix this. What we can do is to just iterate through the result list and just check either we should go uppercase or lowercase, given an index. So we're going to be using an int stream, and they're going to be using the range variant as the end is exclusive. We're going to be joining the result with ng space, and we're just going to check the index. If index modulus 2 is 0 or not. We're going to be either going lowercase or uppercase. Let's rerun the tests. Bingo. So it's correct. So let's now try and run all the tests. Okay, great. So let's try it on the platform. Test first. Looks good. Let's attempt with the full test suite. Great, so we can now submit, but we're not gonna submit yet. Let's see what we can improve. Let's refactor a bit to go full enterprise. So the first thing we can do is to use a phrase rather than a string. And we're just gonna be transforming all those substrings into a phrase object and returning a list at the end. So there is a variant on the stream that is called collecting and then on the collector. What it does is that it applies the collector, in our case the toList, and then applies another function, which is the constructor of the linked list in this case. Let's fix the code to compile. Okay, good. So the next step would be to move the if statement code into the phrase class. Let's create a method called over, for example. So it's a phrase over a next phrase, and yeah, we can pass the is lower than. So it's not a good practice to pass in a boolean to a method, because this means that a method would be doing more than one thing. But in our case, it's supposed to do more than one thing. Let's rerun the tests. All green, great. Okay, now let's try and move the switch cases from lowercase to uppercase into the phrase itself. Now let's keep the names. We're going to be using the index as is. Compile working, good. So the last thing could be to move this whole code into the text itself. Let's create another method that is called arrange, and that it contains all this code. Okay, good. So it's always good to have small methods, so let's move the assembling procedure into a new method called up-down, why not? And let's try to extract those constants into static final variables. We can create a new method for the next. Now maybe we can generalize this add and remove, and to add and remove only once, so keeping a removed index and the string or the phrase that we want to add into the result list. Okay, next phrase and removed. However, in Java we can pass in an object to remove, so we don't even need this removed as long as we implement the equals and the hash code. So we can remove this variable. Let's clean the imports. Looks good. Let's extract this into a next phrase method. Looks good. Let's test. Okay, good. Let's now try it on the platform. Attempt. Okay, so we can submit. Thanks for watching. Now remember to keep calm and keep coding. Until next time. Bye.